In this project, we are building a simple but practical microservice system to understand how modern backend architecture works. The system demonstrates three important concepts. First, microservice architecture, where the application is divided into smaller, independent services such as out and product. Each service is responsible for a specific function, which makes the system easier to manage and extend. Second, we implement load balancing using Nginx. Instead of sending a request to a single server, Nginx distributes traffic across multiple service instances. This has improved performances and reliability. Third, we use Ansible for automated deployment. Instead of manually setting up the system, we define everything in code and deploy it with a single command. However, it is important to clearly define the scope of this project. This system uses load balancing only. It does not include dynamic auto-scaling. That means the number of service instances is fixed and must be configured manually. The goal here is not to build a fully dynamic cloud system, but to clearly understand the foundation of load balancing in microservice. Why load balancing matter? Problem. Before introducing load balancing, let's understand the problem. In a traditional system, we only want instances. All user requests are handled by a single service. This creates several issues. First, the server can easily become overloaded when traffic increases. As more users send requests, the system becomes slower and may eventually crash. Second, this creates a single point of failure. If the server goes down, the entire system becomes unavailable. Third, performance becomes inconsistent under heavy load, leading to a poor user experiences. The solution. To solve these problems, we introduce a load balancer. A load balancer acts as a central endpoint that distributes incoming requests across multiple service instances. This brings several benefits. It distributes traffic evenly, so no single instance is overwhelmed. It improves performances because multiple instances handle requests in parallel, and it increases availability. But even if more instances fail, others can continue serving users. In short, load balancing is a fundamental technique to make systems more stable and efficient. Architecture overview. System design. Our system architecture is simple but powerful. We start with the browser, which sends requests to localhost 8080. These requests first go to the Nginx load balancer. From there, Nginx routes traffic to different parts of the system. The front end is served separately, while backend services are divided into two groups, out and product. Each group has two instances. The key idea here is that we manually define two instances per service. Nginx then distributes requests between these instances. This allows us to simulate a real-world system with multiple backend nodes. However, it is important to note that there is no automatic scaling. The number of containers is fixed. If we want more instances, we must manually update the configuration. This is a controlled environment designed for learning how load balancing works. Request flows. How it works. Let's walk through how a request travels through the system. First, the user sends a request from the browser. Next, the request is received by Nginx, which acts as the gateway. Then, Nginx examines the request path and decides where to send it. If the request is the root path, it is forwarded to the front-end. If the request is API/auth, it is routed to the auth service. If the request is /API/product, it is routed to the product service. Finally, Nginx distributes the request across available instance using a load balancing algorithm. The result is that traffic is evenly distributed across containers, preventing overload on any single instance and improving system responsiveness. Project structure. Organized modular. The project is organized into three main directories: Ansible, Docker, and services. Each directory has a clear responsibility. The Ansible for the content automation script for deployment. The Docker for the define how containers are built and run. The service for the container, the actually application code. Design principle. This structure follows the principle of separation of concern. Each part of the system is independent and focused on a specific role. This makes the project easier to maintain, easier to understand, and easier to install in the future. Backend service. Simple microservice. The backend consists of simple service that run on port 3000. Each service responds with its hostname, which is injected to an environment variable. Why this matter? This small detail is very important for demonstration. When we send multiple requests, we can clearly see which instance handles each request. For example, we may see response from auth number 1 and auth number 2. This allows us to visually confirm that load balancing is working correctly. Docker strategy. Container-based architecture. Each service runs inside a Docker container. This ensures that every service has the same environment, regardless of where it is deployed. Containers are isolated, lightweight, and easy to manage. Benefit. This approach provides several advantages. It ensures consistency across environments. It improves portability, so the system can run anywhere. And it allows for the fast setup, making development more efficient. Front-end. Simple testing interface. The front-end is a simple interface with two buttons, one to call the auth API and one to call the product API. When a button is clicked, it sends a request using the fetch API. The purpose of this front-end is not to build a full UI, but to simulate real user behavior. It helps us interact with the backend and observe how requests are distributed. By clicking multiple times, we can clearly see load balancing in action. Docker Compose. Multi-container setup. Docker Compose is used to define and run on services together. We have multiple containers, 2 for auth, 2 for product, 1 for the front-end, and 1 for the Nginx gateway. Networking. All containers are connected through a shared network, allowing them to communicate with each other internally. Important. The number of containers is fixed. There is no mechanism to automatically increase or decrease the number of instances based on traffic. This reinforces the idea that this system demonstrates load balancing, not scaling. Nginx load balancer. Load distribution. Nginx uses an upstream configuration to define multiple backend servers behavior. By default, Nginx uses a routing algorithm, which means requests are distributed sequentially across available instances. Each new request is sent to different containers. Result: this improves overall performance and reduces the rate of overloading a single instance. It is a simple but powerful technique used in many real-world systems. Ansible automation. Deployment automation. Ansible is used to automate the entire development process. We define roles for different parts of the system, such as setup, backend, frontend, and gateway. What Ansible does: Ansible installs Docker, build containers, start services, and configure Nginx automatically. Fully automated deployment. These eliminate manual steps and ensure that the system can be deployed consistently every time. Dynamic config. Configurable replicates. We define the number of replicates using variable. Important clarification: these values can be trained manually, but the system will not adjust automatically, meaning this is known as static scaling. We control the number of instances manually, which is different from auto scaling system that adjust dynamically based on traffic. Ansible role design. Modular structure. The system uses a modular role design. Each role has a clear responsibility: setup, backend, frontend, and gateway. The principle of separation of automation logic is made the system easier to maintain and allow us to reuse components in other projects. Deployment flow. End-to-end flow. The deployment process follows clear sequences. First, the Ansible playbook is executed, then Docker images are built. Next, the Nginx configuration is generated dynamically. Finally, all containers are started. This flow ensures that the system is deployed in a consistent and predictable way. It also reflects how real DevOps pipelines are designed, even though this project is a simplified version.